Today's lesson is 5.2, perpendicular and angle bisectors. Remember that a segment, ray, line, plane, or plane is perpendicular to a segment at its midpoint is what we call a perpendicular bisector. A point is said to be equidistant from two figures if the point is the same distance from each figure. So equidistance means we're equal in distance. The perpendicular bisectors theorem says in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Let's go ahead and take a look at what that would look like. In our first example, we know that line UC is the perpendicular bisector, and we need to find x and y. So one of the things that's jumping out to me is that we have this perpendicular bisector. This means we can add a few things to our picture. We know that this side of the triangle are equal in length, and this side and that side are also equal to each other in length. This is what the perpendicular bisectors theorem states. So to find x, we can set up the equation 3x minus 5 equals x plus 5, and we'll go ahead and solve that to find x. And to find y, we can say 9y minus 13 equals 2y plus 15. Okay, so we'll just go ahead and solve both of these equations to find our x and our y per the theorem. So remember, you want to look at your x's and make sure that they are on the same side. The line or the equal sign is dividing them, so I'm going to eliminate the smaller one to the other side by doing the opposite operation that I see. Remember, there's a 1 hiding in front, so we end up with 2x minus 5 equals 5. Now I'm focusing over here on the 2 and the minus 5. I have to get rid of the minus 5 by adding 5 to both sides. Remember, I always do the same thing to both sides. And then simply what the color here with the variable x is doing is reminding me to divide by 2. And I get an answer of x equals 5. What I could do to double check that I am correct is I could plug it back in. Sorry, 3 times 5 minus 5 and 5 plus 5. Both of these should equal 10, and they do. All right, now let's go ahead and solve for y. I'm seeing that my y's are on the opposite sides as well, so I'm going to once again eliminate the smaller one. Focusing over here with my y, I'm going to get rid of the minus 13 by adding 13 to cancel it to 0 or to eliminate it to 0. The whole purpose of the canceling, quote unquote, is to make it go away, to eliminate it, so that I don't have that number there anymore. And then remember, whenever I have a number in front of a variable like y, I'm going to divide just like I did on the other one with x, and I ended up with y equals 4. All right. The point of concurrency of the three angle bisectors of a triangle is what we call the incenter of the triangle. Let's go ahead and talk about our angle bisector theorem. This says if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. An angle bisector, just a quick reminder, is a line, ray, or segment that divides an angle into two equal angles. Let's go ahead and take a look at our last example. Yes, our last example. There's two parts to them, and they're just simply asking you to find x in both of the pictures. So if we take a look at this first one, let me go ahead and zoom in on this picture. I can tell that I have an angle bisector because of the 30 degrees here and the 30 degrees here. So they're not telling me it's an they're showing me it's an angle bisector by giving the two equal angles. What does that mean? That means that this part and this part are equal. Why is that important? I can now take these two expressions and I can set them equal to each other to solve for x. So I have x plus 3 equals 10. And that's a quick and easy one to solve. All I simply have to do is move the 3 to the other side by doing the opposite of what I see, and I get 7. And once again, I can go back and plug it in just to make sure that I'm getting the same answer here that I do have here. And a quick check, 7 plus 3, yep, that's 10. All right, let's take a look at our second example and our last example here. In the last example, notice that I don't see that these two angles are equal like I saw in the last one. But what I do see is that this side, this part and this part are equal, and I have a 90-degree. If I have those markings equal, equal, 90, 90, then it is safe to say that this angle and that angle are in fact equal in length. So I'm going to go ahead and set those two equal to each other and then solve for x. The reason I'm going to put the bottom one first is because 9 is smaller than 6, and I want to have the x on the left side. But it's fine to do 6x is equal to, or yes, the 6x plus 14 is equal to the 9x minus 1. All right, it's safe to switch them. The x's are on the opposite sides. Well, that's what that gray line is telling me. So I cannot combine them together. I'm going to move the smaller x to the other side by eliminating it. I'm going to cancel it out, make it equal 0 by addition or subtraction to create a two-step equation like we've been solving. Once I'm done solving this equation, just like the last one, I can go back and I can plug it in to make sure that my two angles do in fact match in length. If I'm worried that I added, subtracted, multiplied, or divided